So here is my molecule of the year, methyl salicylate. My name is Francisco Garcia, and here we go. So this is methyl salicylate. It has a molecular formula of C8H8O3. It's got this benzene ring right here with an attached methyl group. So yeah, that's its form. Here are some physical characteristics and chemical properties of methyl salicylate. It's got a molecular weight of 152.15 grams per mole, has a boiling point of 222.2 degrees Celsius. Its melting point is around negative 8.6 degrees Celsius, and it is slightly soluble in water, mostly insoluble. They found that it's around 0.7 milligrams per milliliter at 30 degrees Celsius. Some chemical properties of it. Its color, it's colorless to a pale yellow. It has a minty or wintergreen odor. We'll actually find out why in a little bit. It's relatively stable, though it can't be exposed to any strong oxidants or bases. And that is because when it is very flammable, it's very combustible, so you can't have it near any open flames either. And it is extremely toxic. It's very toxic. Its oral LD50 for an adult human is 506 milligrams per kilogram, which is fairly toxic. It's a moderate irritant for eyes and skin when it gets into the eyes and skin. I actually found that it is so toxic that around a teaspoonful of it would kill a child. A little dark, but it gets better. Doesn't have any twins. As far as I could find, there were no enantiomers of methyl salicylate, though many molecules have a similar structure to it due to it being an ester of salicylic acid. Its class, it's a benzoate ester that is a methyl ester of a salicylic acid. Benzoate ester because it's that benzene ring attached to an ester group, which also has a methyl group. So its discovery. It was originally discovered in 1843 by French chemist Auguste André Thomas Cohours. This was one of the greatest contributors to organic chemistry in all of history. He was very prominent in that. He isolated the compound from a plant called Gaultheria procumbens, which more commonly known as an American wintergreen. Now, where does it come from? Is it common? Is it rare? It's actually got a lot of different sources. It's produced in a number of different plants, usually as an anti-herbivore or anti-parasite defense. Like I said, it is fairly toxic, so it would be toxic especially to small herbivores, small pests, parasites, things like that, prevent it from being eaten. And it's specifically made in members of the Gaultheria, Betula, Spiraea, and Polygala genuses of plants. Those are pretty much a whole bunch of wintergreens. I believe the mint family's in there as well. It's easily synthesized for commercial use by esterifying salicylic acid with methanol. And a little bit of history. Originally, it was distilled from twigs of Betula lenta, which is a sweet birch, and that plant that Cohours used, Gaultheria procumbens, that American wintergreen. Why I am nominating it for Molecule Hero of the Year, not Villain of the Year, because it is used in a wide number of things that humans have benefited from, past it just being kind of toxic. So it is used in a very, very small amount as a flavoring agent for chewing gum, mints, and candies. It's actually why we have the wintergreen flavor in a lot of those. It's used for fragrance in several products. You can thank it for helping your car and your gym bag smell nice. It's used as an odor masking agent in some pesticides. So a lot of invertebrates, a lot of insects go off of smell. So they use it to mask some of those pesticides. It's also used as a bait for certain insects, because some insects do actually like the smell of it, such as male orchid bees. They use it for research. That way they can actually bring them in. They don't have to go out and capture them. They just set some out and it gets them right to them. And most importantly, it is used as an analgesic in topical medicines like Bengay for muscle aches, joint pain, arthritis, bruises, all those kinds of things. So it is a huge help there, just because it is used for pain relief. Alright, and here are the sources that I used. I used a lot of PubChem and the NIST web book.